Okay, so just a couple of slides. You already took CS102, so you know what is object-oriented programming, encapsulation, inheritance, composition, and all these different things. But in Python, it's a little bit different from maybe Java or even C. So I'm going to provide you the most important properties of creating classes and objects in Python. Of course, Python is mainly a scripting language, but still it allows you to define OOP to better organize your code. You know all the different advantages of OOP, code reusability, modularity, and improve the efficiency of the code. So to create a class, it's defined by the class keyword, and then you provide the name of the class, and then double colon here. So this defines the blueprint for creating objects, and the constructor is created through the special method underscore underscore init underscore underscore. So this is how we define it. For every method that belongs to the class, it must start with self. Okay, so self, this is similar to this keyword that we find in Java, but this is kind of necessary to put in each method that belongs to the class, starting with self. So later on, you can call it by the name of the object. And then you can define the parameters of the constructor to initialize variables. And then we do this. This is the definition of an attribute, self.brand equal brand, and self.model equal model. So this is kind of initialization. If you want to create an object out of this class, so there is no new keyword or anything, just name of the class, and then put the different parameters. So here, when you don't put any initialization, it means you need to initialize this when you instantiate the class. But you can provide default values. If you provide the default values, for example, if I define a default value is Toyota for brand and model Corolla, I can just call my car equal car between parentheses without anything else. So it's going to take the default values.
The brand and the model, they're being defined inside the function. So can we access them from a different function inside the class?
Sorry?
The brand?
Yeah, you can access them. There is the concept of private attributes, and I'm going to talk about private attributes and also public attributes. So the attributes, they are variables that store data for a particular object, and they are categorized by self, so you can initialize them into the constructor. And to define an attribute, you define it using the keyword self.brand. And later on, you can use it outside. And the method, it's function that defines the behavior of an object. It's created, so using the keyword def, and then the name of the function, and then you put self, since it belongs to the class. And then you can do any logic that you want to implement into your function. So CLS, we didn't put self here, but we put CLS. This refers to the class, not to the object. So self, this is a reference to the object when it is created. And CLS, this is a class method. I'm going to talk about this again when we talk about decorators. So this is a decorator here that defines a class method. It's a method that you can access using the class name, not the object. You don't need to مثل ما نسميه static classes, static methods. There is also the concept of static method, by the way, but this is also a class method that can be accessed from using the class name. You don't need to create an object to access this class. And here, cls.wheels equal new wheels. So this is a class attribute as well. This is defined as a class attribute. And this is a static method. Look, static method, it doesn't use neither self or CLS. It's without any, so it's a static method that you can call. So this is an instance method, this is a class method, and this is a static method. The concepts are a little bit different from what you know in other programming languages. In Java, for example, a class method is basically a static method by itself. We define it as static. So the static method do not access class or instance data. Okay, you are not allowed to use self dot something. You know, if you don't put self here, you don't have access to any attribute or to any method of that object. So it's a method that can do general operation, but not on the attributes or the method of that particular class. And the class method operates on the class itself. Okay, again, it's not allowed to access the attribute of an object. So encapsulation, it means grouping the data. We encapsulate the data into methods like using the setter and getter in Java. And method in a class to control access and modification. So self.attribute, if you define an attribute using self.attribute, so this means it is accessible everywhere. If you use underscore attribute, this is considered as a protected attribute. Protected attribute, it means it can be used only within the class, cannot be used by external classes. It's not. So we can make it private by making double underscore here. So this is hidden from the outside. You need to have like a getter or setter method to access this attribute. And now if you want to access this attribute, for example, that is private, you can define a method that allows you to access it, okay, by setting the value, like you use set balance or get balance to access a private attribute. So this is the concept of how to do encapsulation in Python. You define a private attribute, okay, and then you can encapsulate it into a method to allow either the write access or the read access of that private attribute. Is it clear?
Yes.
You can also define abstract methods in Python, and the objective is to hide internal implementations while exposing only the essential functionality. I mean the abstract class as well. So abstract class is defined by the keyword ABC. It means abstract class, and you define a class that inherits from ABC. So if you do the following, it means this class is abstract. You cannot instantiate that class. And you can define abstract method inside this class. It's like a blueprint. It's like a template that later on, or it's maybe this representation is similar to interfaces in Java. Okay, an interface is a class that cannot be instantiated and only has abstract methods. Okay, you can define an abstract method here, and there is no implementation. So later on, another class can inherit from vehicle and provide the implementations of these different abstract methods.
What's class?
You know, it's just there is no implementation here. Okay. Yes, yes. Because we don't have semicolon, so we need to, when defining an abstract class in Java, you put semicolon and you don't provide implementation. So this is the equivalent of an abstract class definition. So to do inheritance, so in Python we have single inheritance and multiple inheritance. We don't have multiple inheritance in Java. Okay, in Java you can only inherit from one class, but you can implement multiple interfaces. In Python you can inherit from multiple classes, and to inherit you can define, for example, this is a class animal, like the parent class or the super class, and then you can define a class dog and you put animal between parentheses here, so it will inherit all the properties and methods from the class animal. And then you can define additional methods depending on your implementation logic. And this is an example of multiple inheritance in Python. Imagine that you have two superclass, one that is called flyer and another one that is called swimmer. You can define a class duck that inherit from both, okay? Because a duck is a swimmer and also is a flyer, so you can have multiple inheritance here in this class. And later on, you can call duck.fly and duck.swim. The two methods in the two different classes will be inherited. Composition versus inheritance. You know the difference between the is a relationship and the has a relationship. Similar like in Python, these are general OOP concepts that are also applicable. So in the previous slide, we have seen how to make inheritance. To do encapsulation, it means a class contains an instance of another class. So for example, here we say that a car has an engine. We don't say a car is an engine. So if you have a class engine here, you can create an attribute that is called engine, and you create an instance of the class engine for that attribute. Okay, so this is the concept of composition. You know, the OOP concept is independent of the programming language, but their implementation can have some differences from one programming language to another. Okay, so in this case, we have composition, and inheritance is when we put the name of the class here in the declaration of the subclass. So we can also use polymorphism. It's the ability to use the same interface for object of different types. It's like here, we have class bird that speaks, okay, another class for dog, it speaks, and here we have two different type of sounds. So for animal in bird and dog, because we don't have typing here, but using this for loop, okay, so we can go through all the elements that are of type either bird or the type either dog, and then we can animal.speak. So speak is defined for the two type of classes, although they are different. But using the concept of polymorphism here is going to be instantiated either to this one or the bird one, depending on the object that is created. There are also special methods in Python, like the toString method that you know in Java. The equivalent of the toString method is the underscore str self, which you can define. So if you define this method, when you print an object, is going to call the toString method. We can also define init. We have introduced init is the constructor to initialize a class. And also we have the length special method, which define the behavior for calling the len function. So imagine that you define this special method here and return self.pages. Let's assume that the pages is the number of pages in the book. So when you call len book, is going to run this method. So there are several special methods, but this is just a sample to be aware of the existence of special method in Python. But the most important ones is the constructor and also the toString method to generate a string representation for any object. Okay, so let's finish by also what we call the decorators. The decorators are functions that modify or enhance the behavior of the method. So this is a decorator for defining a static method. For example, here we define the class circle, and we want pi doesn't modify any attribute. So it just returns the value of pi. So we can define it as a static attribute, and it can be called directly by the name of the class. You can define a class method, same that I have introduced. To define a class method, we use the keyword CLS instead of the keyword self. And now, if you call circle.py, of course, this is going to call the static method. And here we can call circle.unitCircle. So what does it do here? Look, CLS1 is going to call the class itself and will initialize it with radius equal to 1. So when you call circle.unitCircle, is like you want to create a unit circle. Is going to return an object with radius equal to 1. Okay? And since we define this as a class method, we are able to instantiate it using the class name. You don't need to create an object out there. And the property, that's an interesting point. A property, it returns a method like an attribute. How is that? Okay. So look at this radius. It's a method. And it just returns an attribute, which is a private. So when you define it, this is a property, you can call it as an attribute rather than as a method. Because when you call a method, you will put the parentheses to specify that this is a method. When you call it as a property, it's going just to return this value. And for the end user, it doesn't appear that this is a method. It appears like it's an attribute. But the attribute is hidden. It's like having a get method, but instead of calling it as a method, it's just calling it using an attribute. Yes. So this is that a very brief summary. Of course, we can go even more in detail. The most important thing is that you know this concept, and later on you can go back and utilize them into your code. And that's pretty much it with everything related to Python basics. We're going to start from tomorrow with advanced data structures using pandas and NumPy, inshallah.